Final exam review. Everything you need to do for the final exam. That's going to be this afternoon at 2 p.m. All right, so it's all about programming, obviously. So here's what you got to do. There's no questions about Eclipse, but I'm going to walk through Eclipse. But there's no questions about Eclipse. It's all about programming. So I'm going to create a new project, and I'm going to use the new project, a new Java project, as the exam. So I'm going to call this a final exam review. There we go. So I have a new project here, and the first thing I'm going to do is add a file to it so I can write some code. So I'm going to do it the manual way as much as possible. So I'm going to create a class, and the class I'm going to create, and you're not going to do this on the exam, you're going to write the class. So I'm just going to do like a simple one here. I'm going to call this one here main. Yeah. I'm sorry? Sure, sure. Light?
Yeah.
Oh, turn off the light. Yeah, you can turn off the lights, please. Please, turn this one off too if you want. You can see this here much better, probably. So on the exam, you'll write public class main, or public class hello world. And we'll do here, public class hello world, or main, or whatever you're going to call it. I'm going to call it main. This is the part you'll write on the exam. You want to be familiar with things like system in, system out. Well, system out, no system in. You don't have to worry about that. So if I create another class, so for example, if I said, let me just run through a scenario here. I'm going to do the one we did last time with students and employees and stuff. So I'm going to create another class, human. So file new class. This is going to be called human. So I have a public class human, and I'm going to put some data members in the class. So the question you're going to get is going to say something like, create a class called human. Give the human a string name, so string name, and give the human an age. And if you have a typo, don't worry about it. Or if you have a pencil, well, you're going to be doing it with pen and stuff. So integer age. Let's just go like this. And then the exam's going to ask you to write some setters and getters. So for example, or a constructor. So let me review these concepts. So these are data members, or member function, or data members are fields. So if I said create a class human that has two fields, a name and an age. We know that we have a data type followed by the name of the variable we're creating. I've created two of them here. One that's a string type, the other one's an integer type. I stuck them at the top of human. These are things I'm looking for. I'm grading this exam. Doesn't matter what order you stick stuff in, but if I said create a constructor, a default constructor. If I created a default constructor, we know that the constructor, human, as an example, it does not take on any parameters. If you were to do this appropriately, you would actually put an access modifier in front of it. But what I'm showing you is the base constructor. So when I created a human, I could set things, for example, this.name to equal nothing given or unknown. And then I can say this.age is equal 0. Because when an instance of this object is created, I'm not passing it any information for the name and the age. I'm just going to set the name and the age by default to something. Now, if I wanted to be proper, and you would not have any points taken off if I just said create a constructor and I didn't say anything about any access modifiers, but normally we put public in front of it to say that this constructor is able to run from public. We put public, private, protected in front of, these are called access modifiers. Up here you could even do this. You can go private, and then private here. If I said create two private data members, you wouldn't put the word private in there. If I said create a public data member, you'd put public there. Public constructor, private constructor. So the public private goes before the method or before the data. Because these are private, you cannot set and get these things automatically in main. You have to write public methods to set and get the private data, which is why you're creating setters and getters. So if we do that, this is one constructor. So if I write another constructor, and constructors are going to be public. If I say human and I want to say one that does both the name and the age, I can go string n and then integer a as an example. And then I can say this dot name is equal to n and this dot age is equal to a. And I've got a pretty great looking, hopefully, some pretty nice looking constructor here. Yes?
So why you don't put the string name and then integer age, but you put the string n and then integer age?
Oh, I could put n. I could do that. I could do this name. Name. I could do name. I just wanted there to be less confusion. You can call it anything you want. You're taking these two items in on a parameter line. And the parameters are coming in as n and a. And I'm taking this dot name, I'm making it equal to n. If I called it this way, this is actually optional. And if you do this, you're fine too. We use the this to denote that it's this object's name, not this that came in, not the name that came in from the parameter. So this is actually okay as well if you do this and leave out the this dot. If this was name, however, I would have to do this. Otherwise, it's not going to know which name we're talking about. Name and name is equal to name. Well, which name are we talking about? This name. Yeah?
So this name is you define in the public
Yep.
class?
Yep. That's this one up here. This is this name. Belongs to human. Yeah. For consistency's sake, I'm going to just take that out and put this in. This is the way you're probably going to see it more often, actually. Yes?
So the second constructor, why you put the string and the integer for n and a since they're already being
Because the first constructor, are you the one taking the exam? No. Are you? I'm waiting for a student to arrive who's supposed to be taking the exam. Are you taking the exam right now?
Right now.
Or are you doing it later with the rest of the class? Are you taking it early? No, I don't think so. Okay. Anyway, if you don't know what I'm talking about, then that's good. All right. What was your? Oh yeah, this one here. You can create an instance without sending it any parameters. This one you're going to send it some parameters. So let's make an instance so you can see what I'm talking about. Here we have string n and integer a, and we have this constructor. So I'm going to make two instances of this object human. So I'm going to go into main. And I'm going to say human, which is my data type, h1 is equal to new human. That one is using the default constructor because it's not taking on any parameters. I'm going to make another human, human h2, and this is going to be equal to new human. And then the human's name is going to be Bob, and the age is going to be, let's make Bob 21. So now I have two humans. Well, actually, my main's kind of messed up because I don't have public void main in here. Yeah. What is it? Public, public void main. Yeah, I don't think you have to do the args actually. Let's see if it works actually.
So you don't need the static?
Oh yeah, you do need static. Thank you. Public static void main. It is static. Otherwise it's not going to run. Oh, hello. Let's see if it works actually. So I'm going to run it. I'm just looking to see if we have any errors. I might have to actually recreate that one. You don't have to write a main program, by the way. Let's see. Run it as a Java application. Section does not contain a main type. Oh, let's just see real quick here. Let's just see what happened with this. You don't have to create a main, by the way. I'm just going to string arguments. No, actually, I think it'll work without it. But let me just try something real quick. No, it should work without public static void main. Well, I don't think that is required, but let's just see. public static void main. Well, maybe it is. Keep in mind, you do not have to create a main in the program, so don't worry about this. It is required. Man, I learned something new myself. I thought it was optional, actually. So string, yeah, string arguments is required. Wow, okay. In any case, don't worry about it. And if you were to ask about a main function, you can leave it out and just use main. It's not something I'm going to take away points for. That's what I'm trying to say. Actually, let me see. Good question. I just want to make sure you don't have to do a main first. No. 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 Oh, I'm going to tell you in a few minutes. No. Derive. Nope. I don't have to do that. There is a question that says create a driver class main.java. So here's what I'm going to do for you, which is why I wanted to see that real quick. There's about 5 questions, by the way. I'm going to write this on the board for you, so you don't have to worry about memorizing it, because it's kind of trivial. I'll put it up here for you. But you do have to write a main. So I'll put it up here on the board for you. Not something you're going to be required to memorize. And it's certainly not something I would take off points for either. So it says a public static void main. And this is the part I keep forgetting, the string array. That's the method. This is the main method syntax. That way you don't have to memorize it. Because I'm actually kind of sloppy. I use Eclipse so much that I just click that little button and I don't even know it. Seriously. In fact, in C, C++, this here is optional. Apparently it's not over here. So in any case, I wrote that on the board for you so you don't have to memorize that part. In there it says you're gonna create a main function. You're gonna make some instances of some objects that you've created in the previous questions. So that's pretty much giving you the main object here. So let's see. We haven't done anything outside of making some instances of some objects. So I'm going to go back to human now. And I'm going to create some setters and some getters. So are either one of you back there, or are you the same people I asked before? Taking the exam early? No? Okay. Let's see. So I'm going to create what's called setters and getters. So a setter is going to set the data. I'm not going to return anything, so I'm going to make it void. So I'm going to say public void set name, and it's going to take on a string name. I'll do string n. You want to make sure that when you're creating methods, you're putting the opening and the closing brackets in there. You're using the syntax correctly, so there's a data type or a return type for the method. There's a name of the method. This is a set name. And this is pretty much going to do our constructor data. It's going to take this dot name and have it equal to n. And then if I'm going to write, this is called a setter. If I'm going to write a getter, I'm going to get it. I'm going to return it. Well, it's a string, so I'm going to return a string. So I'm going to say public string get name, and it's going to return this dot name. It's called a setter because we're setting the information. We're setting the name to string name. It's called a getter because we're returning the information. It's getting name, so it's returning this dot name. Now I'm going to do the same thing for age, but this time it's an integer value. So I'm going to say public integer, I'll do it void first, void set age, and it's going to be integer a that's coming in on the command line, and then I'm going to say this dot age is going to be equal to a. Oops, age, you're right. Thank you. And then I'm going to say public integer get age. And that one is going to return the age. So it's going to return age. Or it can return this dot age. If you leave the this dot out, it's fine. It's not something I'm going to take off points for. So now I have a set age and a get age. This is what I mean by setters and getters. Also called setters, getters and setters, setters and getters. I don't know. Set the data, get the data, which is what you're doing. If I run those methods, I'm going to run them out in main. So you know where I'm creating them inside of the object. I'm creating an instance of the object in main. And out in main, I'm going to exercise the setters and the getters. So if I set, I'm going to go the name of the object, h1 dot set name, because h1 didn't have a name, and I'm going to set it to Larry. I got Larry and Bob in here. And then I'm going to go h1 dot set age to make this guy 35. It should be 1 here, h1 dot set age. And then if I want to get something, I could return it and print it to the screen. So here's a system.out.println. Remember that one? And I'm going to say, you want to know that one? I'm going to say H2 or H1. Let's go H2. H2 name is, and then I'm going to put a plus in here for concatenation, and then I'm going to go H2 dot get name, and then I'm going to put a semicolon at the end of that line. And I'll put another one underneath here. System, don't know where those pluses came from. System.out.println, and I'll put here H2 age is, I don't know why I'm picking on H2. I don't know. Let's just put H1 in here. H1 dot get age. So now I'm using the setters and the getters. I've set the name and I've set the age for Larry, and his age is 35. And I'm using a system out, and I'm saying that h2.getName and h1.getAge. And I'm printing the contents of the get to the screen. So if I run it, I should now get some stuff on the screen. I say H2's name is Bob and H1 age is 35. H1 is 35? Yeah, it is 35. So those are the setters and the getters. These are called access modifiers, by the way. Public, private, protective. It's kind of access because you're accessing the method or you're accessing the data. In a standard way of creating a program, the human would be public. Classes are always public. The data in the class is always private, and it is manipulated by the public data members, or the functions or methods inside of the class that manipulates the private data. These need to be public. If they're not public, you can't access the data because the data is private. As an example out in main, if I were to do this, you know, I would say like system out. Here, let's just change one of these system outs here. Instead of running a get name, if I did this, name dot name, and I put my mouse over here, it's going to tell me that it's changed the visibility of name to package, or replace h2 name with a getter, or change it to get name, because it's private data, and private data can't be accessed this way. So it'd have to be get name. So I'm going to put in here get name. Are we good so far? That was pretty much the first couple weekends we did, or the first weekend we did. And then we got introduced to inheritance. So I'm going to close main right now, save it. I'm going to close human right now. Now I'm going to write a new class. So I'm going to go File, New, Class, and I'm gonna show you the code after I do the thing here. I'm going to say, what am I going to make? A person? Human. No, let's make an employee. Employee, and they're going to be a superclass of human. And if I do that, I get public class employee that extends human. So you want to write public class employee. The keyword extends. See, this is the same. If I take this part out here, oops, let me just take it out here. Hello. That class looks like this class. Human, public class human, public class employee. If I write in extends human, now I'm inheriting from human. So if I said inherit a class from a class, create a class employee that inherits from or extends the functionality of human, this is what you're writing. It says public class employee extends human. And in human, I don't have to reinvent the wheel. Excuse me, in employee, I don't have to reinvent the wheel. I just use what I already have. What do I already have? Well, I already have a name in, oops, I don't need test anymore. Let's get rid of test. Yes, let's delete test. I already have, let's see, a name and an age. Here's human. I already have a name and an age, so I'm going to add an employee ID to this. So I'm going to say private integer ID. Are you the one taking the test early? Did you guys know what this guy looks like from yesterday? He's a different guy, isn't he? Not this one. Yeah.
It's like a spy.
Huh?
It's like a spy.
I know. Like, what does this guy look like? You know, if you're going to request to take an exam at 9:30, wouldn't you show up at 9:30 to take it? I don't know. I'm just saying, you know. I'm just going out of my way to help him, but okay. All right, so we got the private integer ID. It's an added piece of data. So what do we do here? If we want to make a constructor, we go public, and we're going to call this one employee. And we're going to say this dot age is equal to 0. And now what we don't have age, I'm sorry, this dot ID is what I'm talking about. This dot ID is equal to 0. And if we want to call to super, we put the call, remember from the midterm, we put super up here. And we're making now a call to the human default constructor. So super replaces human. So we get this name is equal to unknown and the age is equal to 0. So right now if I made it a new employee, then my ID, here let's take the ID and make it 99. Just so it has something interesting to look at. And on the human, we're going to make the human 80. And we'll leave the name unknown, just for fun. And then I'm going to go into main. Now I'm going to make an employee. So I'll put the employee up here next to the rest of them I'm making. So I'm going to go employee this time. E1. And he's going to be equal to a new employee. All I have is the default constructor, so that's really all I can use right now. I'll do a lowercase e because to be consistent here. So now if I come down here and I'm gonna take these guys and copy them so I don't have to keep writing this. So now I'm gonna say E1 name is E1.getName. So I can run the methods because he's a human. So e1.getAge. And I didn't set anything here, but I could go system out dot print line e1 ID is, and go e1.get ID. Well, I have to write a getter for this now, which I didn't do yet. So let's go ahead and write a setter and a getter over here. So public void set ID, and it's going to be an integer I, maybe. Let's just do that. And then this dot ID is going to be equal to I. And then public integer get ID is just going to return ID, this dot ID. Same thing we did for the human. We wrote some setters and some getters. So back out here in main, now I have a get ID that works. So now if I run it, I'm going to see that I have the E1 name is unknown, and the age is 80, because remember I changed that human default age to be 80. And then the ID is now 99, because I didn't set it. And here I have the this dot age is 99. This super initialized the default constructor here, ran this one over here, that set it to 80, which is where I got the age at 80 from. If I print out the name, it's going to say unknown. So now I have all these methods available to me, and I have all these methods available to me. If I want to write another constructor, yeah?
Why we don't define the age here?
Because we already have it. So when you use extend, each employee contains everything a human's got. So you take the human stuff, you stuff it inside of the employee, and then you just add to it. We already have name and age in human. Why do we need it? We don't need to reinvent the wheel in employee. We already have it. That's why we did it that way. All right. So let's see. Now I'm going to overload a constructor. I'm going to call a constructor that's not the default. So I'm going to say public. I know this is a constructor because it has the same name as the class. And I'm going to take in three things. I'm going to take in a string name, an integer age, and an integer ID. So I have my default constructor, doesn't take in anything. I have my other constructor that takes in the name, an age, and an ID. I can't go this dot age. Watch this. If I go this dot age equals a, ooh, yeah, here it goes. It's gonna give me an error. I'm gonna hold my mouse over and it's gonna say change the eligibility of age to protected. No, I don't want to do that. Protected data and protected methods are visible in inheritance. But what I'm really doing is I'm not setting this. This is an employee. So what I want to do is this. I need to do this. I need to go super because I want to send it back, and I'm going to send it N and A. If I send it N and A, in here I'm just going to set the ID to I. So whatever this object doesn't own, you super back to the previous object that you inherited from. So if I extended human, and human has name and age in it, when I create an employee that's going to accept a name and an age and an ID, I'm going to super back the name and the age back to the human and set it in the human properly. Make sense? A little bit? So that's how you pass data from one constructor to another constructor, is you use super. Super simply sends it back to human. Because this doesn't belong to this employee. This belongs to human. And human's going to set the data for you. Okay, let's see. So now out here in main, I can create an employee now that does all three. So I'm going to say employee E2 is equal to new employee. So let's see. This is going to be Mo. Mo's going to be 75 years old, and his ID is going to be 100. So now I got Mo, 75, and 100. I can run this method to create the new instance of the object because I have these three, the name, the age, and this ID of the employee. And so down here I can print out, let's just start here, let's just do it this way. Hit a copy. Unfortunately on the exam you can't copy and paste, but the good thing, the good thing is you don't have to write too many lines. I'm not going to have you make an instance of everything, just one. And just print one thing to the screen. So you don't have to, there's no copy and paste capabilities obviously. So let's see, I'm going to change this to E2, and then we'll print out E2's name, age, and ID. Well, it should say Mo 75 and 100. So let's see. Mo 75 and 100 for E2. Yeah.
So, what's the relationship between employee class and main class?
Employee class is a subclass of human. Human's the superclass. Oh, main, they're both instances of objects that are being created. These are instances of objects. So there's two objects of human, two objects of employee. They're two separate objects, but each one of the employees has a human inside of it. Yeah. And then we're running the setters and the getters on them too. So yeah, these are instances of objects that are being created. Very good question, actually. Anything else before we continue? And then along came abstract classes. So this was really probably the end of weekend number 1 or 2 or something, I don't know. And then we were also introduced to the concept of abstract classes. We're like, okay, what's an abstract class? An abstract class contains an abstract method. So if I wanted to make another class here, I'm going to make, let's change employee. No, because I have a problem with that. Let's make another class. I'm going to make an animal class. So I'm going to say, here, file, new, let me just show you the interface real quick. Animal. And animal is going to be abstract. So if we create an abstract class, we have this thing here. It says public abstract class animal. So the difference between this one and this one over here, if we just said public class animal, that's a regular class. When we make an abstract class, remember that access modifiers always go first. So access modifiers, public, private, protected, that will always go first. The second, if I wanted to say abstract, an abstract, if I correctly here, I'll just leave it out for right now because I'll tell you what happens when I put an abstract method in here. If you make an abstract method, you have to make the whole class abstract. And an abstract method is one that's a function prototype or a method prototype that doesn't contain any implementation. It's going to be left. So I'm going to make an animal, and then I'm making a dog and a cat from the animal. So my animal is going to have a name. So let's just start from scratch here. We're going to make just a regular old class. It's going to be called animal. Here's another time. One more run through to make a class. Private string name. And let's do a private integer age. And wow, here, let me see how fast I can type here. Let me make a, let's just do some setters and getters. Here, I'll make a constructor real quick. Yeah, I'll just do the whole 9 yards here. Public, one more time through. Public animal. This is my default constructor. I'm going to say this dot name is equal to mammal. Mammal? Animal. Just a generic animal. And this dot age is going to be equal to 0. It's just born. So 0. And then here we'll make an animal, public animal. It'll take on a string n, and an age, integer age. And this one's going to send this dot name is equal to a. This is the same thing we just did a few minutes ago. That age is going to be equal to a, n, and an a. Exactly what we just did a few minutes ago. I'm going to make some setters and some getters. Public void set age, set name. And this is going to take in a string n. And we're going to spell string correctly. And then we're going to say this dot name is going to be equal to n. And then now we'll get the name. Public integer get name. Oh, not going to be a string. String get name. And it's going to return name. Return name. This dot name. It's really good common practice to actually use this. So let's see. Public integer. I'll write the integer first. Get age. Return the age. And let's set the age to public void set age. And it's going to take on an integer a from the command line. And this dot age is going to be equal to a. Oh, why not? Let's just go ahead and make the other. Oh, I did. Animal, animal. So I just made another animal that's very similar to the human class we just made a few minutes ago. So now what I'm going to do is I'm going to create an abstract method. I'm just going to put it on the bottom here. And I'm going to say public, it's going to be a who am I abstract method. Public abstract void who am I. Oh, let's see. If I hover my mouse over it, it says remove abstract modifier. Oops. Invalid. Who am I? What am I doing wrong here? Make abstract. Oh, okay. Make type animal abstract. Okay. Usually I see it up here actually. Yeah. There's nothing wrong with this syntax. The problem with this syntax is that I haven't made the class abstract yet. So this is the same as if I do this, actually. But if I do this, it's going to tell me to make the method abstract. Add the body or change animal.whoami to abstract. Because I don't have an implementation. If I had an implementation, it would look like this. I'd have an opening and a closing bracket, and I'd do something inside of it. But if I put a semicolon at the end, so the method looks just the same as any other method. But if I put a semicolon at the end and take out the opening and closing brackets, then it becomes abstract. So I can either make this implemented or put the keyword abstract up here. If I put the keyword abstract up here, the messages go away. Oops, I have to put abstract in here. I took it out. So now I have public abstract void who am I and abstract class animal. Because it's an abstract class, I can't make an instance of it. It won't let me. So I'm going to save it, and I'm going to show you what that means. I'm going to save. So animal's good. But now I'm going to go into main, and I'm going to try and make an instance of animal. So I'm going to say animal A1 is equal to new animal. And I'm going to hover my mouse over, and it's going to tell me that animal cannot be resolved to an animal. Well, that's probably because I spelled it wrong. And animal is a type now. But it's going to tell me that can't instantiate the type animal because animal is an abstract type. I can't make an instance of animal. Instead, I can only inherit from animal. So if I inherit a class from animal, I'm going to create a dog now. So if I do that, I'm going to go File, New Class, Dog. I'll do it manually this time. So I've got a class dog, public class dog. Same as before, I'm going to say extends animal. If it extends animal, if I hover my mouse over here, it's going to tell me that I need to add the unimplemented method. So now I actually have to put the method in here. So a dog is an animal. All I have to do though is create, so I've got the rest of it in animal. Animal has the name and the age and everything, but it has this abstract method, who am I? Well, so I'm going to put it in dog. I'm going to say, if I hover my mouse over, I can save myself some typing, but let me just put it in manually so you can see what I'm talking about. Just write the method. Public void, what was it called? Who am I? Who am I? Now I've satisfied the requirement. Now I'm going to have it do something. System out, print line. I'm a dog. I'm a dog named. And then I'm going to say this dot get name. Because I'm inside of this object, I don't have an instance. If I wanted to, I could just do this actually, get name. But I don't have an instance. I'm this inside of this object. This is my identity. I'm inside of myself. So normally you'll see this in front of it, or you'll just see get name. Get name is a method that belongs to this. So now out here, if I create a dog, which I can do, so I'm going to say dog, my dog, is equal to new dog, Fido, and Fido is 21, and I think that was it, right? That's about all Fido had. And what's wrong with this one? Oh, I don't have a constructor in dog. Remove arguments to match dog, dog. I didn't put a constructor in dog. So let's do the same thing I did with human. I'm going to put a constructor in here. I didn't add any data, but I still need to put a constructor in here. So public dog. Oh, that's about all I need. And let's see. There's my constructor. So, well, let's just make another one here. I'm just going to say string name, integer, age, and then I'm just going to super back N and A. Because I didn't add any data to this method, I'm showing you something else actually. Because I don't have any data in here, I'm just going to basically pass the data back to animal. And animal has a constructor that takes on a name, hopefully has a constructor that takes on a name and an age. But in dog, I don't really setting anything. So now I should be able to run, because I have this constructor inside of dog, I should be able to run the constructor and make the instance of the object. So now I could put in Fido, and then I could put in 21.
Shouldn't it have like
You probably should put a default one. Yeah, you probably should put a default one in here.
I mean, without like declaring a customized like constructor, should it have like?
It does. It has this by default. You don't actually have to put this in.
Yeah, but if there's one by default, why does main like show the error? I mean.
Oh, it had an error because I was putting the parameters in,
Okay.
and I didn't have that one.
Oh, I see.
See, this one I could just do this. I'm just gonna run to super.
Yeah.
Yeah.
So what if you don't want super?
But nothing actually. It's by default. It's gonna run super. If it's a default constructor, every default constructor will run of the object if you don't create another. If you don't use another one, that's why they call it default. It's the one that's gonna run anyway. So even if we didn't do super here, it would work anyway. Even if we left this one out, actually, it would work anyway. So now if I run it, oh, let me see what I did out here. I made a dog. Let's put them at the top. System. Ooh, what did that dog do? The dog had a who am I in it. Let's just run who am I on the dog. Because the who am I is void, it's not returning anything. Instead, it's just going to run a system out. So I'm just going to run who am I. And I'm a dog named Fido. That's what it's going to come up with, hopefully. So I'm going to type this one. I'm going to say my dog dot who am I. It's going to print out I'm a dog or something like that named Fido. Yeah, it says I'm a dog named Fido. And so now I'm going to make a cat. So I'm going to do the same thing as I did before. So I'm going to extend animal again. So I'm going to shut this one here, file, new, class. This one's going to be called cat. And now I'm going to extend animal. So cat extends animal. And I'm going to add the unimplemented method here, just because I don't feel like typing here. This one's going to say system out, print line. You know what? Why type? Why type when you can do this? But this one's going to say I'm a cat. Cat named, get name. So let's go put a constructor in here. I'm going to just steal this one out of here. Just change dog to cat. There we go. So now I'm a cat. And so now if I make an instance of cat out here in main, I would do the same thing as I do with the dog. Well, let's just do it this way then. Why type when I can cut and paste? So now it's going to be cat. My cat is going to be equal to new cat. Felix. Felix. Cat. This cat's an old cat. This cat's going to be 30. My cat. So this one should hopefully say that I'm a cat and my name is Felix now. So I'm a dog, I'm Fido, I'm a cat, I'm Felix, and then the rest of it's what we had before. So what we've done now is we've created an abstract class, animal, and it's the abstract class, and it has this method in here on the bottom. This is an abstract method. Abstract method lacks implementation. It's just a method prototype. In fact, it's the first line of the method with a semicolon at the end of it instead of the implementation. And we've delayed the implementation until we've gotten to dog or cat that extends animal. Now we have this other concept called an interface that we looked at. I'm going to put an interface in here. I'm going to close some of these things so I don't get confused here. Review the concept of interfaces. So if I say file, new, interface, I'm just going to do this so I can get it written here. It's going to be called print me. Actually, yeah, I'll call it print me. Why not? I always call it print me. Now I use, instead of public class, so this is the only difference here, it would be say class. Public class print me. It's another class. And if I wanted to make it abstract, I'd go here, abstract class, print me. If I take class out, well, you can't have an abstract interface, so let's take abstract out first. If I replace the word class with interface, I get the equivalent to an abstract class. But the thing with the interface is that all you get is no implementation. All you get is the abstract methods or abstract data. So for example, if I come back up here to dog, no, let me go back up to animal. Animal has all this implementation inside of it. It has lots of stuff in it. The difference between this animal is this is an abstract class. Some of it's implemented, some of it's not. We have at least one abstract method. In the interface, nothing is implemented. So in here, we have public, void, show a show name. So I don't see abstract in here. I don't see anything in here. I could put abstract in here if I wanted to. If I put abstract, it's going to be just the same as an abstract class, but instead it's a method prototype. So in the other one we did this, abstract. That works too. Abstract is just going to make you implement it. If I just do this, and then I'm going to put two of them in here. Public, void, another. If I save the interface, I see I've got two methods in here. I've got show name and another. They're not abstract. They're just, it's an interface. It's assumed that they're abstract. The use of the word abstract is actually optional. If you put it in there, it's just fine as well. There's a lot of people that will take an abstract class, make it into an interface, but then they remove the implementation.
So and also then there's no way like to make implementation about the function here.
Yeah, there's no way.
The,
Yeah, if it's an interface, you're not going to put any implementation in here. It's kind of like the .h file is to the .c++ file, if you're familiar with C++. It means that these are method prototypes. They're assumed to be abstract, so you can leave the word abstract out of there. But the reason why we're doing this is because in dog, I extended animal. I can't do this. I can't put a comma in here and then put print me. Because what's going to end up happening is it's going to say delete these tokens. It doesn't. You can only extend one class. If you want to add more functionality to it, then you implement. So it implements print me. And if it implements print me, I've misspelled it. Create class implements. Interface print me. Implements. What did I misspell? PL implements. There we go. Thank you. Hold on. That other error is expected. It's not really an error. I'm going to show you in a few seconds here. So I have public class dog extends animal implements, if you spell it correctly, print me. And if you misspell it with an I, which I do all the time on the final, no problem. I'm going to know what you mean. You're allowed to make typos on the final. Okay, so if that's the case, I'm going to hover my mouse over dog and I'm going to say that add unimplement. It's just like an abstract class. It's just the same thing as putting another abstract class in. Problem is you can only extend one class, but you can implement as many interfaces as you want. So if I do that and I press on add unimplemented method down here, I've got the two of them. I'm going to get rid of all the syntax that came with it. But now I'm just going to put, same thing as I implemented the abstract methods. Now I'm going to implement, and I don't really even have to put any bodies in there. I just have to implement the show name and the another. I just have to put the method bodies in there. So for example, if I would have created another interface, let's just go ahead and do that. I'm going to save this here. Oops, I can figure out how to save it. Save. So let's see, file new, let's just do another one. I'm going to call this another one. There we go. So now I got an interface, another one. And in this one I'm going to put public void one, thing one and thing two. Let's do thing one and thing two. There we go. You guys know cat in a hat? Thing one. I don't know, I'm just making up names right now. Public void thing two. Thing one and thing two. Looks pretty good to me. This is another interface, public interface, another one. So I'm going to save this one. And I'm going to come back up to dog up here in the top. And I'm going to put a comma in here. I'm going to put another one. And then it's going to come back up to dog and it's going to say implement unimplemented methods. And I'm going to say, okay, yeah, add it. Now I have thing one and thing two from another one that got put in. So you could put in as many interfaces as you want. The only stipulation is that you need to you need to add the unimplemented methods to the class that it is coming. So that the class that's using the interface. So this implements print me, and another one is implementing these interfaces. And these interfaces are these methods that are over here in the interface.
So what if you don't put extend, but then just put implement for all the classes?
Oh, you could do that too. Let's pick another one. File, new. What kind of animal have we not created yet? Dog, cat, fish. Fish. So now I have a public class fish. Well, that's going to implements. There we go with my spelling again. It's going to implement. Let's just have it do another. No, print me. And then I'm going to need to add it. So let's just put it in here. Public void. What is the one? What's in the? Well, let's just do it this way. That way. There's two of them. There's a show name, and then there's another in there too. So this one just implements. You don't have to extend anything. It's just going to implement print me. So how does that work then? If it's a fish, then, and it implements print me, I can create a fish, and then I can run show name. Let's say system.out.println. Because it doesn't have any data in here, I'm just going to type I'm a fish. I'm a fish. So show name is going to print I'm a fish. So I can still make an instance of fish. So out in main, I'm going to go fish my fish. Fish my fish. It's going to be equal to new fish. And then I'm going to say fish.showName. Oops, my fish.showName, excuse me. My fish.showName. And it's going to print out, I'm a fish. It implements print me, but it doesn't extend animal, so it doesn't have a name or an age. In fact, I can put something in here and do some setters and getters and do all that stuff all over again, but I don't know. I think you've seen it already. So if I do that and run it, it's going to tell me that fish is going to be I'm a fish. Here it is, I'm a fish. So the interface can be used with inheritance or without. It is very similar to an abstract class, but nothing inside of it is implemented. In an abstract class, I can actually take, where did I have her? Human? Let's go back and take human, make human abstract. Class human. I can actually just do this if I wanted to. Abstract class human. Which means I can't make a human. So if I go back to main, I just made human abstract. No biggie. I changed it after the fact. If I go into main, I'm going to have to change this H1 here. Let's just take it out because I can't make an instance of human. But actually here, let's change this one to employee. Employee H1. Add a cast employee. Yeah. I can make a human and cast it to an employee. Not such a good idea though. It's better not to make. So it's better, let's just do it this way. Let's take this out.
Is that because of this unsafe?
Well, the problem is that employee is higher up in the hierarchy. I don't want to cast it that way. It's really, if you make a human abstract, do we have a new employee?
You don't have this kind of constructor.
I don't have that employee, right? Actually, I have to do this. 200, there we go. That constructor is not an employee. So now I can't make any more humans, but I just took that out. So now I have humans instead of employees because I made H1. It's all going to work, but I can't make you can't make an instance of an abstract class just the same way as you can't make an instance of an interface either. So if I did like, what is our interface called? Print me. So if I said print me, it's going to be equal to new print me. It's going to come back and give me an error message. And the error message is going to say that you can't instantiate the type print me. It's an interface. You can't do it. But if I wanted to make a cat, and a cat uses print me, I can do this one here. Now I got a new cat. Oh, do I have a cat? No, I don't have a cat. I don't have a cat default constructor. So I had to put in a default constructor here, public cat. Now I can make a cat with a capital C. Java is case sensitive, by the way. So now in my main, this cat should work just fine. So what else you need to know? Let's see. Take a look here. I got the file in front of me actually right now. Let's see. Interfaces. Abstract classes. Everything we just did. Constructors, setters and getters. Inheriting a class from a class. Yep. The only thing I didn't show you was inheriting a class from a class from a class. Let's do that next. That's it. Inheriting a class from a class from a class from a class from another class. Let's just take the hierarchy a little bit more here. It's the same thing, actually, if you think about it. All right, so what do we got here? Let's go back to employee. Let's make a teacher that's an employee. That would be inheriting a class from a class from a class. So I'm going to make a new class. New class. This one's going to be called teacher. Teacher. And teacher is going to extend employee. Now we got a class from a class from a class. A class from a class from a class, yeah. Teacher is from employee, employee is from human. Human is abstract, doesn't really matter. So let's send some stuff back. Actually, this is really easy. The only thing you know is each object takes care of its own stuff. So for example, if we had a private integer social security number. And let's make a constructor then for employee, excuse me, for teacher. So we say public, the teacher's constructor, it's always the same name as the, class. Except for I had to spell teacher right. There you go. This dot the social security number is equal to 555. There we go. That sounds pretty good. And I'm going to run super. And you know, super is always showing up as the first line in the method. We know that from the midterm, hopefully. It always shows up as the first line in the constructor. You have to do something first. Actually, a little trivia on the way objects are created. The base object is always created first, which is why super always shows up first in the methods for the constructors, because you have to go back. You have to send the information first so that the base classes can be created, and then the classes on top of that can be created. So. All right, so let's see. I'm going to make another constructor here. This one's going to, what's employee got? Employee has a string name, integer age, ID, integer ID, and then we're also going to do social security number, integer S, SS, SN. Were you here before? No, you just showed up. Oh. It's okay. String name. So let's see, this teacher's going to be Barb. And she's going to be 21. And what was her ID? 100. And everybody I have 100. Let's go 300. My social security number is going to be 666. Ooh, that's a lucky number.
Wait.
No, I can't do that. I have to do this. Hello. There we go. SN. There we go. Now we got it. If you got that part, you're sending it back to employee. And you have a constructor inside of employee. Where's employee? Here it is. Inside of employee, you've got a constructor that matches the one that you just used, that takes on 3 elements. This is the one here, takes on 3 elements. When you send it this way, you're sending 3 of the 4, this one has 4 elements, you're sending 3 of them back to employee. And employee is going to take those 3, send 2 of them back to human. So it's called chaining. It's constructor overloading, or chaining, or supering back. So the highest level teacher sends those 3 back to employee. Employee sends 2 of those back to human. And it's all automated. So if you were to run a teacher, let's go into main. If I were to say teacher, new teach, it's going to be equal to a new teacher let's do this correctly here. I just realized I did this completely wrong. And it's I, there we go. I just realized I did this completely wrong.
But it doesn't matter.
It worked. It would work.
Yeah,
It would actually work. But I was making the instance in the object itself instead of outside in main. I want to send back N, A, and I, which is why I'm taking them on the command line. So if I were to actually run the constructor, then I would send it the information I want to run it. So this is where I would put the Barb in there. And she's 21, and her ID is 300, and her social security number is 666. There we go. And so then, because teacher is ultimately a human, I could pull her age out. I could say get age. So I could run this one here, actually. Here, let's just run. Let's run. It doesn't matter in main where I'm sticking this stuff either. I could just stick it wherever I want. New, let's call this something else. Let's call this new T1. Let's go T1. Let's be consistent here. T1 is equal to T1. It's easier for editing. T1, T1. So now I have a T1 name, age, and ID. Because I could do a get. In teacher here, I could do a get social security number. Let's do that actually. Public void set SSN to integer SN. And then usually you want to do setters and getters and pairs. So this dot SSN is equal to SN. And then one here that says, well here I'll just rewrite it. Public integer get SSN is going to return SSN. This dot SSN. So now I can get the social security number here as well. So in main, I can do this here actually. Actually, let's just do it this way, SSN. Everybody good? So far? It's good? You're gonna ace the final if you got all this. This is the content of the final exam for those people who keep asking me over and over again, what's on the final? This is on the final. this is the final. Except for you'll be doing it on a piece of paper and a pen, and you won't be doing it on a computer. It's a little different, and you won't be doing as much. So you won't have to do as much programming. So you have a T1's name is Barb, and T1's age is 21, and T1's social security number is 666. That's it, actually. That's the entire final exam, believe it or not. It's everything you ever wanted to know. And that person who's taking it right now should not be in the room. No, maybe they should be. You guys are in the room. You're going to take it later. So, you guys done? All done? Okay, hold on one second. Let me cancel this recording.